Okay, boys, welcome to day 2 of Unit 1B. And today, the first thing we want to do is bell work. So you want to go ahead and pause the video. We're on page 6 in your packet. Pause the video and complete the bell work. Okay, welcome back. And so I'll show you the answers to the bell work. I'll enlarge that so you can see it. Okay? And if you have any questions on this, you can ask me during our synchronous learning time, or you can send me a text on Remind. What determines if it's narrow, wider, or the same? If A, the coefficient, if A is greater than 1, it makes it narrow. If A is less than 1, it makes it wider. And if A is equal to 1, I guess I should say the absolute value of A. The absolute value of A is equal to 1, then it's the same. Okay? And so if you need to take a picture of that, but if you have any questions on that, you can ask me during synchronous learning time, or you can send me a remind. Okay? All right, so we're still on page 6 of your notes. We're going to do pages 6 and 7 in your notes. And our objective today is to write an absolute value function as a piecewise function. Okay? So before we do that, let's just kind of look at a piecewise graph. So let's say we have the graph y equals x minus 2. So what do we know about this graph? From yesterday, we know that its vertex is at -2, 0. The axis of symmetry, which is always the x-coordinate of the vertex, is x equals -2. So if we were to graph that, and it has a slope of 1. So if we were to graph that, we would start at -2, that's where our vertex is, then we go up 1 over 1. And then we do the same thing on the other side. And so what we can see is that this is broken into 2 pieces, 2 linear functions. One has a slope that's positive and one has a slope that's negative. So we can break this into 2 different, so let's call this A, and let's call this side B. Now what do we notice about these 2 different sides? Well, one, this slope is negative. I could spell slope, S-L-O-P-E, and this has a positive slope. Each of the slopes, each line has a slope of 1 or -1. So m is equal to -1, m is equal to 1 on this side. And they break up at the vertex. So that's when we get a new function, is at the vertex. So those are 2 of the things that we've noticed, and we're going to label 1, the slope on the line on the left as A, and the line on the left as B. So the domain on the left, so the domain of line A goes from -infinity to -2. The domain of B goes from -2 to infinity. Now, which one of these I include is up to me. It doesn't matter which of these you include. So I'm just going to go ahead and include the one on top. So let's write an equation for the graph on the left. One of the things we notice is the slope is negative. So it has a negative slope of 1. So we know it has a negative slope of 1. What is its y-intercept? If we were to continue this graph, if I keep going down 1 over 1, down 1 over 1, we'd see that it has a y-intercept of -2. Now, the graph on the right has a positive slope of 1, and we can see that it has a y-intercept of 2. So what I want you to notice is that our original function was y equals x plus 2, the absolute value of x plus 2. Notice that this is the same as this. Okay? What I also want you to notice is that this is the opposite of this because of the negative slope. Okay, so so if I were to take a negative, put it out here, so if I put a negative out here and do x plus 2, I end up with negative x minus 2, which is the same as this. Okay, that's what I want you to notice because that is important. So what do you notice about the two equations? So we notice a couple of things. They both have the absolute values of the slopes are the same. And they're opposite of each other. Okay? So that's what we're going to recognize when we write the piecewise function. So what we're going to do is the one graph is going to be exactly the same. The graph on the right will be exactly the same. And the graph on the left is always going to be the opposite. Okay? So let's just kind of put that in words for a little bit. So the graph, this function breaks into pieces at the axis of symmetry. It breaks into pieces at the axis of symmetry. And so therefore the boundaries are going to be negative infinity to h and h to positive infinity. Okay, where h is the x coordinate of the vertex or the axis of symmetry. It's also the axis of symmetry. Okay? All right. So, just to kind of get a hand of this, let's just kind of sketch this graph. So this graph has a vertex at -4, 0. So the axis of symmetry, excuse me, is x equals -4. Okay? So, and I'm going to label this A and B. So A, the graph on the left, is always the opposite of what's inside of here. So the graph on the left, we're going to say it's negative because it has a negative slope, x plus 4. The graph on the right is whatever's inside of here, it's the same. So this would be x plus 4. Okay? And it breaks up at -4. So I'm going to go from negative infinity to -4. And then from -4 to infinity. And it doesn't matter which of these I include. Doesn't matter. So distributing this negative, I get negative x minus 4. If I distribute that negative, so this becomes negative x minus 4. This one remains the same. Okay, let's do the next one. So we can see that our vertex here is going to be 2, 5. So that graph would look like 1, 2, and then 5 up. So it looks like that. Okay? So my axis of symmetry is x equals 2. That's where my graph is going to break up. So I can go here and write negative infinity. I can write negative infinity, but for some reason I wrote -2. So I'm going to go from negative infinity to 2, and then 2 to infinity. Okay? So the graph on the left, A, is always the opposite. So it's going to be negative x minus 2, close parenthesis, plus 5. This is y of A. Okay? So distributing that negative, I get negative x plus 2 plus 5 combining like terms, I get negative x plus 7. The graph on the right is always going to be exactly what's here. So that is just x minus 2 plus 5. So this is YB. So that is just going to be x plus 3, combining like terms. And that's what we got. Okay? So how about this? Pause the video and I want you to try the third problem. Okay? Welcome back. So what we see here is our axis of symmetry, our vertex is at -3, -1. That's our vertex. So when I sketch that, I get, not that. So we have -3, -1. So we'll go 1, 2, 3, down 1. And that's my vertex. That's my graph. Okay, so the axis of symmetry is x equals -3. And remember, the graph on the left will be the same. So if I call this A, so y of A is equal to -2 times x plus 3 minus 1. Distributing, I get -2x minus 6 minus 1. So I get -2x minus 7, and that's going to be broken by the axis of symmetry, so it goes from -infinity to -3, and I'm just including that just to be different. The second one remains the same, so y of b, this is b, is simply 2 times x plus 3 minus 1, which is 2x plus 6 minus 1, so 2x plus 5. And that's going to go from -3 to infinity. Okay? So remember, what we notice is the graph on the left is always the opposite form. We always take the opposite of the graph on the left. So now this one is a little different because this one is going to be upside down. My vertex is at -4, 0. So my axis of symmetry is x equals -4. And its slope is 1, but it's facing downward because it's negative. So remember, we always take the opposite of the one on the left. So this is a little bit trickier. So if this is part A, y of A is equal to negative parenthesis x plus 4. Okay, so what does this do? So what we're going to see is that this makes this negative. If I distribute this negative, I get -x minus 4. Then I have to distribute the negative again, so I'm going to get x plus 4. And that makes sense because notice that this has part A has a positive slope. And that's what I'm looking at. So part A has a positive slope, and I have that. And we also notice that if we continue this graph, that this would intersect the y-axis at 4. Okay? And so I am still going from -infinity to -4. And then I'm going to go from, including this, -4 to infinity. And then the second one, it just remains the same as it is. Notice that B has a negative slope. So when I distribute the negative, I get -x minus 4. Okay? And if I were to continue this graph, I'd see that it would intersect the y-axis at -4. So that makes sense. Okay? So the one on the left is always the opposite. The one on the right, we write exactly the way that it is. So I'll just do one more. So this has a vertex of 1, 3. 1, 2, 3. So 1, 2, 3. 1, 3. And again, it's negative, so it's upside down. Excuse me. Alrighty. And so the axis of symmetry is x equals 1. So everything is broken by 1. So I'm going to go from negative infinity to 1. And then from 1 to infinity. Okay? And so the first one, the one on the left, A, is always the opposite. So that's negative, negative, parenthesis x minus 1, close parenthesis, plus 3. So distributing this first negative, I get negative parenthesis x plus 1 plus 3. And now I have to distribute that negative again, so I get negative x minus 1 plus 3. So that is negative x plus 2. The last one, the second one, the one on the right, remains the same. So that becomes negative x minus 1 plus 3, which is negative x plus 1 plus 3. And that's negative x plus 4. And I can see that if this continued on, if I had drawn that remotely correctly, we would see that that would intersect the y-axis at 4, and this one would intersect the y-axis at 2. All right, pause the video, and I want you to do the last 4. Do the last 4, and then come back and I'll do them with you. Okay? All righty. So the first one, I'm not going to do all the sketching. I'm just going to kind of give you the vertex is negative 2, negative 5. The axis of symmetry is x equals negative 2. And so we're broken up from negative 2, from negative infinity to negative 2. And then from 2 to infinity. The first graph would be negative, negative, x plus 2 minus 5. So that's negative, negative 3x minus 6 minus 3. So 3x plus 6 minus 3, which would be 3x plus 3. And that goes with that one. Then the one on the bottom remains the same, so that's going to be 3x minus 6 minus 5. So we get 3x minus 11. The one on the left is always the negative one. So my axis of symmetry is x equals 1. My vertex is at 1, 2. So the one on the left is always negative, so that's going to be negative 3x plus 3 plus 2, which is negative 3x plus 4. So we got 3x plus 4, and we're starting at 1. And then the second one will be exactly the way that it is. So that's 3x minus 3 plus 2. So that's 3x plus minus 1. And that's going to go from 1 to infinity. Okay, so the vertex is at negative 6, 0. The axis of symmetry is x equals negative 6. So that means it's broken up from negative infinity to negative 6, and from negative 6 to infinity. The one on the left is always the opposite, so it's negative x minus 6. The one on the right is always the same. One of those should be in a bracket. Okay? Again, our axis of symmetry, our vertex is negative 3, negative 4. The axis of symmetry is x equals negative 3. So the one on the left is going to be the opposite. So it's negative, negative 2x minus 6. I just went ahead and distributed that, minus 4. So that is 2x plus 6 minus 4. So that's 2x plus 2. And the second one remains the same, so it's negative 2x minus 6 minus 4. So that's 2x, negative 2x minus 10. And this would go from negative infinity to negative 3. And then from 3 to infinity. Okay? All right, that's it for today's lesson. You want to do your homework that's listed on the Google Classroom site. And I will see you guys or talk with you tomorrow. Again, if you have any questions, just send them to me through Remind, or you